Today in this video we are going to discuss a very important theorem which has a very vast use in the study of probability, that is Bayes theorem. And the statement is, if A be any event which may occur in the succession of either of exhaustive events E1, E2, E3 and so on to En, then the conditional probability of an event ER when it is given that A has happened is given by P ER partition A is equal to P ER into PA partition ER upon PE1 into PA partition E1 plus PE2 into PA partition E2 plus so on to PER into PA partition ER plus so on to PEN into PA partition EN, where R may have any natural number value, that is 1, 2, 3 and so on. This is called Bayes theorem. Now let us have a glance once again. Bayes theorem. If A be any event which may occur in the succession of either of exhaustive events E1, E2, E3, and so on to En, then the conditional probability of an event ER, when it is given that A has happened, is given by PER partition A, where PER partition A indicates the conditional probability of ER when A has happened, is equal to PER into PA conditional ER upon PE1 conditional into PA conditional E1 plus PE2 into PA conditional E2 plus so on to PER into PA conditional ER plus so on to PEN into PA conditional EN, where R is equal to 1, 2, 3 and so on to N. Now, for more comprehension, let us take an example. An insurance company insured 2,000 scooter drivers, 4,000 car drivers, and 6,000 truck drivers. The probability of an accident involving a scooter driver, car driver, and a truck driver is 0.01, 0.03, and 0.15 respectively. One of the insured person meets with an accident, and what is the probability that he is a car driver? Now we have to give the solution to this problem. So let A is equal to the event the insured person meets with an accident, and let E1 is the event the person is a scooter driver, E2 the person is a car driver, and E3 is the event the person is a truck driver. So we need to find out PE2 conditional A or PE2 partition A, because conditional probability is denoted by partition, the probability whose conditional probability is found, and that is written first, and partition, after partition on the right hand side of the partition, that probability is written which is given to be happened. So PE2 conditional A is required. Now by Bayes' theorem, PE2 conditional A is equal to PE2 into PA conditional E2 divided by PE1 into PA conditional E1 plus PE2 into PA conditional E2 plus PE3 into PA conditional E3. So first we write this in the form of the formula of Bayes theorem. It facilitates us to think that what we have to find out. So first we need to find out PE1, and according to our assumption, E1 is the event that the person is a scooter driver. So first, we have to see in the problem where is the suitable information. As it is given in the problem, the insurance company insured 2,000 scooter drivers. That means there are 2,000 scooter drivers out of 12,000 insured persons. That is 2,000 plus 4,000 plus 6,000. That is 12,000. So out of 12,000 persons, there are 2,000 scooter drivers. So the probability that the insured person is a scooter driver that is PE1, that is equal to 2,000 upon 2,000 plus 4,000 plus 6,000, that is equal to 2,000 upon 12,000, which is simply equal to 1 upon 6. Make it equation number 1. Similarly, PE2 is equal to 4,000 divided by 12,000, because there are 4,000 car drivers and total number of the drivers are 12,000, so 1 upon 3. Similarly, PE3 is equal to 6,000 because number of truck drivers are 6,000 divided by 12,000 because total number of drivers are 12,000. 6,000 will divide 12,000 two times, so we have 1 upon 2. Now we need to find out PA conditional E1. That means the probability of A when E1 has happened. So E1 is A is the incident that insured person meets with an accident, and E1 is the event that the person is a scooter driver. So A conditional E1 means when the person is a scooter driver, what is the probability that he will meet an accident? So its answer is given in the problem itself, and that is 0.01. And similarly, PA conditional E2 is equal to, when E2 has happened, that means the person is a car driver, then the conditional probability of A that he will meet with an accident, that is given in the problem as 0.3. Now, PA conditional E3, that is given in the problem. As we know that E3 is the person is a truck driver, then if the person is a truck driver, what is the probability that he will meet an accident? That is called PA conditional E3. which is given in the problem as 0.15. Now, we have to substitute all these probabilities in this formula. So, P E2 conditional A is equal to PE2, which is equal to 1 upon 3 multiplied by PA conditional E2, which is 0.03 divided by PE1, which we have calculated as 1 upon 6 from equation number 1. So 1 upon 6 multiplied by PA conditional E1, which is already given in the problem as 0.01, plus PE2, that is the same which is written in the numerator, 1 upon 3 into 0.03, plus PE3, which we have calculated as 1 upon 2 multiplied by PA conditional E3, which is given in the problem as 0.15. Now we have to simplify this expression to find the required probability. So here we know PE conditional E2 conditional A is equal to 1 upon 3 into 0.03 is 0.01, and here this can be written as 0.01 upon 6 plus 0.03 upon 3 and plus 0.15 upon 2. Now 0.01, and in the denominator let us take LCM, which is 6, and in the numerator we have 0.01 plus 0.06 plus 2 3 is 6, 3 into 0.15, that is 0.45. Now, as 6 is the denominator of denominator, it will go in the main numerator. So we have in the numerator 0.01 and 2, 6 upon, let us add all these terms. So 5 plus 6, 11, 11 plus 1, 12, 2, 1 carry, 1 and 4, 5, 5 plus 0, 5, plus 0.5, so 5.0. So 0.52 is equal to 0.06 upon 0.52. Now, as these two decimals are like, so we may erase the decimals and get 6 upon 52. Both are the numerators and denominator, both are divisible by 2. So we have 3 upon 26, which is the required probability